So hello everyone, this is our second lecture of ice cream. In the previous lecture we have discussed the definition of ice cream, composition and the dairy ingredients which are used in preparation of ice cream. In this video we will see the non-dairy ingredients which are used in preparation of ice cream. So the non-dairy ingredients are like sweeteners. So why sweeteners are used? They are used to increase the acceptance of the product. Also they are used because they increases the viscosity and total solid of the mix. So this is very important, like they increase the viscosity and also the total solid of the milk. Also they improve the body and texture, and they decrease the freezing point, which means slower the freezing. And if the freezing is slower, then they require the lower hardening temperature. If lower hardening temperature, then it will save the cost. So in plain ice cream we have used the 14 to 16% of sugar. So also in fruit or chocolate ice cream we use about 17 to 18% of sugar. And also the amount of sugar is very important. Like if the amount is too little, a very small amount of sugar is used, then the ice cream should have a flat taste. If too much sugar is used, then also they mask the desirable flavor, like the desirable flavor for which the consumers are eating this, it masks, means it disappears the flavors that are desirable. So types of sweeteners: first one is nutritive and second one is non-nutritive. What is nutritive sweeteners? Like they provide the calories or energy. Like example we have sucrose, dextrose, invert sugar, corn syrup, maple sugar, honey or brown sugar. And we see the second type, which is non-nutritive. They provide no calories or no energy or zero energy, and also they are much sweeter than sugar. Also they are known as intensive sweeteners, intense sweeteners. Also they have a variety of example, like saccharine, which is 300 to 500 times more sweeter than sucrose. Second one is aspartame. Third one is sucralose, which is 600 times more sweeter than as sucrose. Stevioside, which is a plant origin from the stevia. And also S-sulfame K, which is 200 times more sweeter than sucrose. Second one, non-dairy ingredient is flavoring agents. Like flavors, the main source of consumer appeal or refreshing effect or cooling effect. Like flavors are produce the refreshing and cooling effect, and also it is the main source of consumer appeal. Also we have various types of flavorings, like vanilla and chocolate. They are dominant flavors. They are mostly used flavors like vanilla or chocolate. Now we see the types of flavorings. Types of flavorings like natural flavorings, fruits, citrus, non-citrus, cocoa, chocolate, coffee, vanilla beans and nuts. So these all are included in natural flavorings. In synthetic flavoring we have aromatic chemicals. In liquor flavoring we have alcohol, whiskey, brandy essence, etc. Now we see the vanilla. So these are extracted from the orchid vanilla fragrance. Active compound is vanillin. In vanilla the active compound is vanillin. In chocolate they are extracted from theobroma cacao beans. Now we see the coloring. Like ice cream should have delicate attractive color matching its flavor. Exception like chocolate ice cream, they don't have required coloring, because chocolate ice cream has itself is brown color. So type like synthetic and natural, we have a synthetic and natural. Examples of synthetic color: red color produced from erythrocene, allura red and Ponseo 4R. Brown color produced from caramel or brown HT. Green color produced from green S, fast green FCF. Orange color produced from sunset yellow. Yellow color produced from tartrazine, and blue color produced from brilliant blue. Indigo produced from indigo carmine, and black color produced from black PN. Now we see the examples of natural colors. Like yellow color produced from annatto, which is produced from bixa orellina, and curcumin, which is turmeric. Brown color produced from caramel, from sugar, and saffron hue should be produced from carotenoids, basically from saffron. Now we see the flow diagram of preparation of ice cream. So we first do the selection of ingredient. Now after the selection of ingredient, we will do the formulation of mix, like how much amount of ingredient we are required for making the ice cream. Now after the formulation, we do the blending of ingredients, then homogenization is done, and homogenization is done at two stages, like we have studied in our previous videos. If you have not seen these videos, please go on channel and write homogenization so you can see that. Now homogenization is done at two stage. In the first stage we do at 2500 psi pressure, and second done at 500 psi pressure. After the homogenization, we do the pasteurization for removing the pathogens, bacteria, and also it is done in two ways. Like for small quantities, we do the batch pasteurization of about 69 degrees Celsius for 30 minutes, and for large quantities at industries, we do the continuous pasteurization at 80 degrees Celsius for 25 seconds. After the pasteurization, we do the aging of about 4 to 12 hours at 0 to 4 degrees Celsius. After the aging, we do the freezing of mix at -4 to -5 degrees Celsius. Then we do the packing. After the packing, it is sent to the hardening tunnel for about several hours at -23 to -29 degrees Celsius. After the hardening, we do the storage at -18 to -20 degrees Celsius. Now we see the each step in detail. Like for the first step, we do the preparation of mix. For preparation of mix, we do the selection of ingredients. And ingredients, we have two types of ingredients. First is dairy and second is non-dairy. In dairy, we have milk, cream, butter, SMP, WMP and SCM. SMP means skim milk powder, WMP means whole milk powder, and SCM means sweetened condensed milk. Now the non-dairy ingredients like sweeteners, colors, flavors, stabilizers, emulsifiers, fruits and nuts, etc. Second step is formulation of mix. We have various methods: algebraic method, Pearson square, computer based, formula tables. We will understand the first one, algebraic method. Now we have to prepare 100 kg of ice cream mix. So to prepare 100 kg of ice cream mix, and we have also given the desired composition of ice cream mix, and it has fat of about 10%, sugar 15%, SNF 11% and stabilizer 0.5%. So we have given this desired composition. Now we have also given the ingredients, like we have milk, SMP and cream, but we don't know the quantity of milk, SMP and cream. We only know the fat and SNF. Like milk has 6% fat, 9 SNF, SMP has 40% fat, 5 SNF, cream has 1% fat and 95% SNF. It is reverse, like it is written wrong here. Like cream should have 40% fat and 5 SNF, and SMP has 1% fat and 95% SNF. Please correct that. So now we let the quantity of milk, SMP and cream be X, Y and Z. Now we have make here three equations. Like first one for total equation, like the 100 kg, in which X, Y, Z are the milk, SMP and cream, and for sugar we multiply with the original amount of the mix, means we find the 15% of the total, and for stabilizer we do the same for 0.5% of the total. And second equation we made for fat, like we don't know the quantity, but we don't know the quantity of fat, but we know the quantity of we know the fat and SNF. So from this we make the two equations, and after solving these three equations we get X, Y and Z. We get X, Y, Z, then we can find the total. Like if we add all of these, like milk, cream, SMP, sugar and stabilizer, we get total 100 kg. So this is how we calculate the amount of or formulation of mix. Now after the formulation of mix, we do the blending of the mix. First, liquid ingredients are mixed and heated at about 40 to 50 degrees Celsius. Also, if sodium alginate is mixed with the portion of sugar at 71 degrees, like if we have to add the sodium alginate, so it should be mixed with the portion of sugar at 71 degrees Celsius. When gelatin is used, it is dissolved 9 times water by weight. If gelatin is used, so it should be dissolved 9 times water by weight. Now, after the blending of mix, we do the homogenization. Generally, homogenization is done at 65 degrees Celsius in two stages. Like first stage is 2000 psi and second stage is done at 500 psi pressure. So, what is the advantages? Advantage is more uniform ice cream. Okay, if we do the homogenization, it should be more uniform ice cream. We get the more uniform ice cream. Also, it smoother the texture, shorter the aging period, and less stabilizer required. If we do the homogenization, we require less stabilizer. Okay, now we do the pasteurization. So pasteurization is done at 69 degrees Celsius for 30 minutes. It is LTLT, and 80 degrees Celsius for 25 seconds STST. It is done to destroy all the pathogenic bacteria. Advantage is improve the flavor, improve keeping quality, and better body and texture. Now after the pasteurization, we do the aging of mix. Like keep the mix at 0 to 4 degrees Celsius, and aging time should be 4 to 24 hours. What does aging? So aging does the crystallization of fat, and it increases the viscosity of the mix. After the aging of mix, we do the flavoring. Like we add the flavoring like fruit pieces, nuts, and other added after freezing. So keep in mind that after freezing we should add this type of flavoring, because if they added before freezing, then it will create the ununiform or crystal form, the crystal formation, and the ice cream mix should not be uniform. So they should be added after freezing and before packing. Also, fruits are added at the rate of 10 to 25% of mix, flavor added at the rate of 1 ml per liter, and nuts are added of about at the rate of 1 to 5%. Like after the flavoring addition, we do the freezing of mix. In freezer, mix converted into ice cream by aerating, freezing, and beating the mix. About 50 to 60% of water in mix will be frozen during freezing. Keep in mind that about 50 to 60% of water in mix will be frozen during freezing. Like we have a continuous freezer in which dasher and scraper. So dasher helps to wipe the mix and incorporate the air inside the mix. Scraper scraps the ice crystal so that on the surface of continuous freezer, it scraps the ice crystals. It is frozen. The ice cream is frozen to -4 to -5 degrees Celsius in the continuous freezer, and the average size of the ice crystal should be 40 to 50 micrometer. And if more ice crystal, if the size of ice crystal is 50 micrometer, then coarseness defect occurs. After the freezing, we do the packing in the cups or in the fiberboard cartons coated with wax, or cups made of paper or cardboard coated with wax. After the packaging, we do the hardening, and the temperature of hardening should be -18 degrees Celsius. And quick hardening is essential to minimize the ice crystal growth, otherwise leads to sandiness defect. Now last step is the storage. Then it is stored at -23 degrees Celsius to -18 degrees Celsius. Then after the storage, we do the distribution in the refrigerated trucks of about -18 to -20 degrees Celsius. Now what is overrun? Overrun is the excess volume of the ice cream obtained for given volume of the mix used. Percentage overrun is equal to volume of ice cream minus volume of mix upon volume of mix into 100. Now you can calculate the overrun of the ice cream. So thank you everyone. This was the lecture of preparation of mix or ice cream. Thank you everyone.